Hello everyone. Let's talk about unsafe rust. As we are all aware of the memory safety functionalities offered by Rust, let's see how can we can make a Rust code unsafe and why do we have to make a Rust code unsafe? So, however, Rust has a second language hidden inside itself that does not enforce these memory safety guarantees. It is called as unsafe Rust and it works just like a regular Rust, but it gives you extra superpowers. Now let's see what are these extra superpowers that are offered by the unsafe Rust. So the first power that you get is dereferencing a raw pointer. The second one is call of an unsafe function or method. The third one is access or modify a mutable static variable. Fourth one is implement an unsafe trait. And the last one is access fields of unions. To switch to unsafe Rust, we just have to use the unsafe keyword and then we start writing the code into a new block that holds the unsafe code. So it is important to understand that the unsafe does not turn off the borrow checker or disable any other Rust safety functionality checks. If you use a reference in an unsafe code, it will still be checked. The unsafe keyword only gives you access to these five features that we have spoken about, but you still get some degree of safety inside the unsafe code. In addition to unsafe code, it doesn't mean that the code inside the block is necessarily dangerous or it will definitely have some memory safety function problems over here. The intent of this is that the programmer ensures that the code inside the block is an unsafe code and he wants to do memory access in a valid way. But as we are humans, we tend to make mistakes. So it is important that we try to minimize our mistakes in the unsafe block by trying to keep the unsafe block as safe as possible. And how do we do that? Is that we try to make it as small as possible. So to isolate our unsafe code, we can even create a safety API above it, which we will discuss later along in this chapter. Let's look at the first superpower of unsafe Rust, that is dereferencing a raw pointer. So, if you go through chapter 4 of dangling references in the Rust book, you will come across that the compiler ensures references are always valid. Unsafe Rust has two type of references that is called as a smart pointer and a raw pointer. So, as raw pointers can be immutable and mutable itself. So, as you can see, you have created two raw pointers over here, that is asterisk const I32 and that is R1 and R2 is asterisk mute I32. So what are the possibilities that we can use by this raw pointers? So raw pointers are different from the smart pointers in the following ways. The raw pointers are allowed to ignore the borrowing rules by having both immutable and mutable pointers or multiple mutable pointers at the same location. The next thing is that the raw pointers aren't guaranteed to what you say point to a valid memory locations and they can be null and they don't implement any automatic cleanup type. The question here we get that why are we uh, ignoring the Rust safety features? So by ignoring the Rust safety features, in exchange we are getting greater performance or an ability to interface with another programming language or in hardware. That does not guarantee that the Rust rules have been applied over here. So now as you can see in this example, we have created two raw pointers that are immutable and mutable over here. So as we can see that while creating the raw pointers on line number 4 and 5, it is not necessary to create them into the unsafe block, but create when you're dereferencing the raw pointers, it is important that we dereference them into the unsafe block and we ignore the rushed safe memory safety functionalities. Here we created these two raw pointer using the as keyword, which has created two pointers, that is the immutable pointer and a mutable pointer. But over here, we assure that the reference is to a valid memory location. So dereferencing them in the unsafe code wouldn't be any risk over here. So when I run cargo run over here, you can see that the value at the memory location is 5 and 5. But what if we want to show you, if we create a raw pointer that is not pointing to a like some random memory location over here, like let me see. So let's create a pointer that is pointing to an undefined location or a specific memory location into the memory. So over here, we are trying to use an arbitrary memory which is undefined. So when I say undefined, that there might be data at this specific memory address or there might not be. Or the compiler might even optimize the code so to try to reduce the memory access over here. Or the page fault might occur when we try to dereference this. Usually, this is not a good reason to write a code, but if you need to go for hardware registers, you may use this code. Let's see the second operation, that is calling an unsafe function or a method. The calling of an unsafe function or a method you can perform in an unsafe block is calling an unsafe function. Unsafe functions are just like a normal function. They look very like a regular function, but they have the unsafe keyword before the definition. The unsafe keyword in this, as you can see over here, is the unsafe function dangerous. The unsafe keyword in this context indicates that the function has requirements we need to upload when we call this function, because Rust can't guarantee that we are meeting all the requirements. By calling an unsafe function within an unsafe block, we are saying that we have read the function documentation and responsibility for uploading all the functions. Their behavior is safe. Here in the function, you can see that the dangerous function has been defined over here, and while calling it, it has been called into the unsafe block. So when we must always call the dangerous function within a separate unsafe block. If we try to call it outside, we might get an error. So if I just comment this in here, you get an error saying that this operation is unsafe and requires an unsafe function or a block over here. With unsafe block, we are telling the Rust that we have the whole responsibility of this function and we have read the documentation and we understand how to use it properly, and we have verified that its complete usabilities. Body of unsafe blocks are effective on unsafe blocks so to perform other unsafe operations within the function, and we do not need to add another unsafe block over here. In this section, we're going to see using external functions to call external codes. So sometimes your Rust code might need to interact with codes written in other languages. For this, Rust has to use the external keyword that facilitates the creation and use of foreign function interface that we call as FFI. The FFI is a way of programming language to define functions and to enable a different programming language to call those functions. So as in an example, in this example, you can see that we have integrated the ABS function from the standard C library. The function declared within the extend block are always unsafe to be called from a Rust code. The reason behind this is because Rust, the other language, does not enforce the Rust rules and guarantees the Rust safety functionality. So Rust can check them, and the responsibility lies on the programmer to ensure that these functions that have been used are safe to be used. Within the extend C block, we just have to give the name and the signature for the external function. So over here, you have seen that we have given ABS and the inputs are as. The C part over here defines the application binary interface the external function uses. So it defines how the function is going to be called at the assembly language and which line programming language is going to call it. The C ABI is the most commonly used function calls over here. We can also call Rust function from other programming language. So to do this, we can use the extend to create an interface that allows the other languages to call the Rust function. Instead of creating a whole extend block, we just add the extend keyword and specify the API that we want to use, the API that we want to use before the function keyword. So over here, we also need to add the no mangle annotation over here to tell that the Rust compiler not to mangle with the name or function name. So mangling is just when a compiler changes the name of the given function to a different name that contains more compiler specific information. To avoid this, we put the no mangle annotation over here. The next feature that we are going to see is accessing or modifying a mutable static variable. That is a global variable which we have not yet spoken about, but Rust does support them. They can be problematic with Rust ownership rules. If two threads accessing the same mutable global variable, it can cause a data race. In Rust, global variables are called as static variables. So in this example, as you can see that we have the use of a static variable with a string slice as a value. Static variables are similar to constants, which that their name of the static variables are into the screaming snake case by convention. Static variable can also store references with static lifetimes, which means that the Rust compiler can figure out the lifetime and we aren't required to explicitly mention it. Accessing an immutable static variable is safe. A subtle difference between the constant and immutable static variable is that the values in the static variable have a fixed address in the memory. Using a value will always access the same data. Constant, on the other hand, are allowed to duplicate their data whenever they are used. Another difference between the static variable can be the mutable. Accessing and modifying mutable static variable is unsafe. The next feature that we're going to speak about is implementing an unsafe trait. We can use the unsafe to implement an unsafe trait. A trait is said to be unsafe when at least one of the method has some variant of is that are unsafe into the unsafe block. We can declare that a trait is unsafe by adding the unsafe keyword before the trait and marking the implementation that the trait is also unsafe to use. And the last and the final one is accessing fields of union. So here a union is basic similar to a structure, but only one declared field is used in a particular instance at a time. So union are in primarily used in interfaces with unions in C codes. Accessing union fields is unsafe because Rust can guarantee these type of data currently being used or stored in the union instances. So for the takeaway from this video, we see that whenever you're using an unsafe, there isn't anything right or wrong to be decided upon this. But it gets a bit trickier when you're using an unsafe code because the compiler can't help you with the memory safety functionalities of Rust. When you have a reason to use an unsafe code, you can do it. So, and you have to just use the unsafe keyword. But make sure that you are coding at the right way. Thank you.